We have our Smart Pilot example, and the difference between that, the last example we did called the Dumb Pilot, and this one here, the Smart Pilot, is that rather than in the Dumb Pilot example where we think we want to go straight east, so we point the airplane due east, and then it turns out instead of reaching, say, if we were going Cedar Falls to Dubuque, rather than ending in Dubuque, the wind is pushing us 2 degrees south, so we don't end up where we want. The Smart Pilot is going to look at the wind, look at the direction they need to go, and say, I need to point the nose of my aircraft a different direction than I want to land because I'm accounting for wind. The wind will push me towards my destination so that by the time I have traveled the distance I want, I've also ended at the direction I want. So if you read through, it says you're flying a helicopter from Waterloo to Mason City. The heading is 310. So that 310 is like on a map. If I start in Waterloo and I look at where Mason City is, the direction is 310 degrees. So if we want to draw that, let me change that. So over here, what that looks like, we've got north here, so we got north, 310, remember 310 for a heading starts at north, and here we go, 90, and then straight down is 180, around here to the negative x is 270, so we need to go an additional about 40 degrees, okay, so this is 40 degrees to get us from the 270, right, so if we went all the way around from north to here, that's 310 degrees, sorry. And this 40 degrees is going to come in handy here in a minute. But that vector itself, that vector we would call P plus W. Okay, now the reason we're calling it P plus W is after we account for the wind and the direction and speed of the airplane, or sorry, the helicopter, as well as the speed and direction of our wind, if we account for both of those things, our resulting vector of where the airplane is heading is needing to be in that 310 degree mark so that we eventually land in Mason City and not somewhere else. Let's see, what else do we know? Oh, all right, so we'll call it red. Our wind vector is next. We'll look at that next. And that says that the wind is from 80 degrees at 40 miles an hour. And again, just like the other example we just got done doing, we're going to, so we're gonna say, remember 80 degrees, so I'm gonna draw a dotted line. Not the best, but that's 80 degrees from north, which is what this heading is telling us. So that kind of gives us right, so here's 80 degrees here. That leaves us with 10 more degrees here. Now, that's the direction the wind is coming from, right? So the wind is coming from this direction, which means that the wind itself is actually, I'm going to draw it short, just like I did in class, because the length of the vector does truly represent the vector itself. So if P plus W, this whole thing, is the speed of the plane plus the wind itself is just a section of that. So I'm going to draw a really short vector, and we're going to call that W. Sorry, and I did forget to put the little arrowhead things on top. Okay, but anyways, so we have the two pieces of information that are given now put onto the map. So what we need to find, I guess really this should be a green arrow because that's our resulting vector P plus W. So it's asking what heading and indicated airspeed do you need to fly? So the question at hand is, no longer, given the direction and speed of the plane and the direction and speed of the wind, where does the plane end up going? This question is, we know where we need to end up going after we account for wind. The question is, what do we need the airplane to do? Where do we need it to face? So what that really looks like is, see, we'll spell it out this way. We know P plus W. Okay, that vector, remember that's the magnitude times cosine of the direction or the angle, comma, magnitude times sine of the angle. If we do that, we need to know what is the magnitude. At this point, we haven't discussed that. It says, you know the heading, and it is 61 miles. So we know we have 61 miles to go. And it says we want to fly directly there in exactly 30 minutes. So that is 1/2 of an hour. So 61 miles in a half hour, I'm going to write it this direction, is 122 miles per hour. So that's the magnitude of the plane plus the wind pushing or pulling it needs to be 122. So that's our magnitude of P plus W. And the angle itself, again, now that we're back into trigonometry and cosines and sines, we need to go back to this angle here, and we need to find this theta, this angle here, because that's what we use, that's what we always use for trigonometry. The 40 we put out here earlier is going to help us. So if I go from 0 all the way to 180, I'm back here at the negative x. I know that I'm 40 degrees short of that because of what we discussed earlier. So if we take the 180 minus the 40, we get cosine of 140 degrees. And then 122 sine of 140 degrees. Okay, so 122 is the speed based on the information given. We have to go this far in this much time. Angle we figured out there. So this is simplified to -93.457, 7842. That makes sense. Negative x, positive y. So negative x, positive y, that does put us right where we need to be. The other vector that we know is the wind vector. So we're going to call W our wind and say the wind is, well, the magnitude is given to us. We're told it's 40 miles an hour. We need to figure out what angle we're at. Let me move this. There we go. Red. So what we need to find here is now from here all the way through to this guy. So here we've got 0 on the x-axis. We go all the way to 180 plus that little extra. So if I bring that out, well, I don't know what geometry term that is, but if I go from the positive x up 10 degrees, it's the same as taking the negative x and going down 10 degrees. So we went 180 plus 10, so we went a total of 190 degrees. And then 40 sine 190. Degrees there, okay. That simplifies. And that should both be negative, hopefully, because we're in the third quadrant. So negative 39.39 and negative 6.95. So that checks out. So here we have P plus W, our resulting vector. We also have our wind vector, just W. So if we have P plus W and we just want to know P, we can say P plus W minus W, and then the W's go away and we're left with P. So what we need to do, in essence, here I will call it blue. So in other words, if we take P plus W minus W, we get P. Okay. In other words, we take the resulting x of P plus W minus the x of W, and we get, let's see, negative 93 minus negative 39. We get to add 39. So we get negative 54.07. And then the 78 plus negative 7, essentially is 695. That is 8537. So believe it or not, we haven't actually answered either part of the question, what is the heading and airspeed, fly this mission. Problem is, all we told you was the resulting P vectors, X and Y components. So at this point, we can tell you that you're going to go negative 54 in the X and 85 in the Y, but that's not helpful if we want to know the heading. It is useful to some degree. The airspeed, well, the airspeed is just, what they're really asking for is the absolute value of P, right? The magnitude of the vector. And the magnitude of any vector is the X component squared plus Y component squared. And then you take the square root. So speed, airspeed. Airspeed is just if you solve that number, and we get 101 miles per hour. Something to be cautious, if you run this number in your calculator and you get an answer, I think it's around 64 or 65, somewhere in there, miles per hour in your answer. Just a quick PSA, what's happening is the calculator is taking the 54 and squaring it and then replacing the negative again. So we know negative 54 squared is going to end positive. The calculator, if you type it in a certain way, and you just do negative 54 squared, it'll still give you an answer of negative whatever the answer is. So please be careful. If your answer is 64 something, that's what happened. If it was me, I know my negative 54 is going to end positive. If I type it in my calculator, I'm going to type it in as just the 54.07. I would leave out the negative sign, just as a quick PSA. I'm running out of time. I only got about 2 minutes here. So the last thing we got to do is create our angle. And let me set up that picture quick. Sorry, I paused the video quick, and now we got a bunch of stuff showing up. So to cover this in a minute and a half, the heading itself, if we use the P vector, negative 54, so like imagine this is your axis right down here. So our 54 over 85 up, we can find this angle, we call it alpha. So tangent of alpha is 85 over 54. That gives us, if you take the arc tangent, we get 58 degrees. The 58 degrees is over here in the second quadrant, and we know that our heading has to be theta. That heading has to start at, sorry, I did that wrong. Hold on. Really messed that up. Our heading, sorry, has to start at north. I was going to use the cosine. We're going to go all the way around here. So if I do the black arrow to 270 degrees from north, we got 270. We still have to add 58 degrees. That means that 270 plus 58 is 328 degrees, and that is our heading. So the answers to the question are airspeed of 101 and a heading of 328. It makes sense because if the wind is kind of pushing us, we don't have to go as fast for the overall speed that we needed. So there we go.